Welcome to the Western Province first term evaluation of 2018 for grade 7 mathematics. So write your name in this blank. Time given for this paper is 2 hours and we will answer part 1 first. They're asking us to answer all the questions on the paper itself and telling us that each question carries 2 marks. Right. So we can first, it's ideal for you to attempt all these questions on your own, and if necessary you can get your parents' assistance. Right. We'll start with question number 1. Here they are saying draw all the axes of symmetry of the following figure. So when they tell you to draw, use a pencil. Here we have the shape of an arrow, except both sides have the arrowhead. So when we look at it, we can see that there will be an axis of symmetry from the middle, from here to here, this way. Because if you fold it along this line, you see that the top part and the bottom part, they are equal and they overlap onto each other. Then we can also figure out that there will be another axis of symmetry from the middle. So what you can do is take your ruler and measure this rectangle, and somewhere in the middle you can draw another axis of symmetry like that. So basically, since the middle shape is a rectangle, we can start off by drawing those two axes of symmetry that you would anyway have for a rectangle, and then see, are there any others? No. So leave it at that. 2 axes of symmetry, and we get 2 marks there. Moving on to question number 2. If the following statements are true, put a tick, and if they are false, put a cross in front of each statement. Part A. In a bilaterally symmetric figure, the 2 parts on either side of an axis of symmetry are equal in shape and in area. So in bilateral symmetry, like here, this is a bilaterally symmetric figure. So if we take 2 parts on either side of the axis of symmetry, say this part and this part, they are equal in shape. The top part and the bottom part here are equal in shape and in area. So that statement is correct. We put a tick. Part B. When you fold a plane figure along a straight line, if the 2 parts obtained are equal in area but not coincide, the folded line is called the axis of symmetry. Coincide means they must overlap onto each other and fall on each other. So if they don't coincide, we don't consider the folded line as an axis of symmetry. So we take this one as a wrong answer. You put a cross. Wrong statement. Part C. Number of axes of symmetry in a square and rectangle are equal. Right. So that one. So from this part we figured out that the number of axes of symmetry for a rectangle is 2. From the middle vertically and from the middle horizontally. That's for a rectangle, it's 2. For a square, we know that we have the vertical one, the horizontal one, and diagonally this way and this way. We have 4 altogether in a square. So number of axes of symmetry in a square is 4. In a rectangle, it's 2. They are not equal. It's a wrong statement. Put a cross. Part D. There will be 2 axes of symmetry in a bilaterally symmetric figure. No. There can be more than 2. The square is a bilaterally symmetric figure. It has 4 axes of symmetry. So there is no must. It's not compulsory for the bilaterally symmetric figure to have exactly only two axes of symmetry. So this is wrong. Put across there. Question number. Yeah. Right. Question number 3. Write the set A equals digits of the number 3666 by writing all the elements that belong to A within curly brackets. So all the elements which belong to A within curly brackets. Digits of the number 3000. So first write 3666. Write the set A equals digits of the number 3666 by writing all elements that belong to A within curly brackets. So number is 3666. What are the elements of A? The numbers are 3 and 6. So 6 is repeated thrice. So we can just write it again. Once is enough to represent the 3 sixes because it's the same thing. Question number 4. Express the set A equals A, E, I, O, U in a Venn diagram. So draw A and put A, E, I, O, U in a Venn diagram, and usually we can put the universal set like this. Right. Question number 5, part 1, simplify. 8 plus 3 multiplied by 5. So here we have to use BODMAS. BIDMAS. BIDMAS. So we have to check. Do we have brackets? Nope. Indices? Nope. Division? No. Multiplication is there. So first we do the multiplication. So that is 3 into 5, that is 15. 8 plus 15. Right, after that what's left is some addition, so we do the addition. 23. Here, brackets no, indices no, division no, multiplication. So do the multiplication first. 5 into 8, 40. Then what's left is a subtraction, so that is 32. Right. Question number 6. Find the value. So again we have to use BIDMAS. BIDMAS. Are there brackets? Yes. So do the bracket part first. 15 plus 14 minus 5 is 9. Division by 3. Right. So after brackets are done, are there indices? No. Division, yes. So 9 divided by 3. That is 3. So then what's left is the addition. That is 80. Right. Question number 7. From the following, select and underline the numbers which are divisible by 9. Right. So if the numbers are divisible by 9, you know that the sum of each digit of the numbers must be divisible by 9. So here we add 2 plus 1, 3 plus 0, 3 plus 6, 9. 2 plus 1 plus 0 plus 6 is 9. And 9 is divisible by 9. Therefore, this is divisible by 9. Then we take 8 plus 3, 11. 11 plus 4, 15. 15 plus 2, 17. 17 is not divisible by 9. So we don't select this. This is not divisible by 9. Check this one. 5 plus 6, 11. 11 plus 2, 13. 13 plus 8, 21. 21 is not divisible by 9, so this is not divisible by 9. So all you have to do if you want to check if a number is divisible by 9 is add all its digits and see if that total is divisible by 9. Here we have 9991. 9991. So at once we can tell this is not divisible by 9. Because if you try to divide this by 9, what happens? You get 1, 1, 1. 99901 remainder. So that's not divisible by 9 either. So only this first one is divisible by 9. You can check it by adding also. 9 plus 9 plus 9 is 27 plus 1, 28 is not divisible by 9. Right. Moving on to page 2, question number 8. The number 19 blank 2, basically 1900 blank 2, the tens place is blank, is divisible by 6. Find the suitable digit for the empty space. Right. So if a number is divisible by 6, that means it is definitely divisible by 2 and 3. 2 and 3. Right. Since the unit place is 2, it is already divisible by 2. So now we have to make sure that this is divisible by 3. For this to be divisible by 3, the total, just like previously we did for 9, we have to check if the digital root, the total of these units has to be divisible by 3. So if we get 1 plus 9 is 10, 10 plus 2 is 12. 12. So if you put a 0 here, 1 plus 9 is 10, 10 plus 2 is 12. 12 is divisible by 3, so you don't need to add anything. You can put a 0 here to make sure that it is divisible by 3. Or, if necessary, other suitable numbers, you can make this 1 plus 9 is 10, 10 plus 2 is 12. So if the total is 15, that means you can put a 3 here. Or if the total is 18, you can put a 6 here. Any of these numbers will be divisible by 6. So we can leave it as either 1962 is divisible by 6, 1932 is divisible by 6. You can double check that. 1932. Yeah, so like that. Even 1902. So if 1932 is divisible by 6, 1902 is divisible by 6, 1962 as well, because the difference is 30. Right. Question number 9. Write 60 as a product of its prime factors. Right. So divide 60 by first prime number 2, then you get 30. You can divide that by 2 again, we get 15. Then we can't divide this by 2 anymore, we can divide this by 3. We get 5. Divide this by 5, you get 1. So 60 we can write as 2 into 2 into 3 into 5. And this 2 into 2 we can write as 2 squared into 3 into 5. Now let's check. 2 squared is 4. 4 into 3 is 12. 12 into 5 is 60. That's correct. Find the highest common factor of 2, 3 and 5. So the factors of 2 are 1 and 2. Factors of 3 are 1 and 3. Factors of 5 are 1 and 5. So the highest common one is 1. So that is 1. Question number 11. In A cube, write the base. So the base is the bottom number, the big one here, A. Index is the power, which is 3. Question 12, part 1. Expand and write the product 5 cube into A squared. So what we can do is, we can write this as 5 to the power 2, A to the power 2 multiplied by 5. Because 5 into 5 squared is 5 cube. Then we can write this as 5 into 5a to the power 2. Write this as 5. Because square belongs to both the 5 and the a. Write part 2. Write the expression using index notation. 2 into 2 into 2. How many 2's are there? 3 2's are there. P into P. How many P's are there? 2 P's are there. So it's 2 cubed into P squared. 2 to the power 3 into P to the power 2. Question number 13. To which century does the time period from 2001 AD to 2100 AD 2100 belong? So this would be the current time period, which is also known as the 21st century. Simple, really. Just remove these two zeros and we get 21. That is the 21st century. Question number 14. From the following years, select and underline the leap years. Right. So, leap year should be divisible by 4. At the same time, if the last two digits are 0, 0, it should be divisible by 400. So 1900 is divisible by 4, 1900 is divisible by 4 but not by 400. So this is not a leap year. 2000 is divisible by 4 and 400. 4, and because the two zeros at the end, it's divisible by 400 here as well. So this is a leap year. 2004 is 4 years after this, so it's a leap year. It's divisible by 4. 2010, so 2004 is a leap year, 2008 is a leap year, 2012 is a leap year, 2010 is not a leap year. Question 15. ABCD is a rectangle. If there are parallel lines, indicate them using the parallel notation. So yeah, so this is parallel to this, and this is parallel to this. Right. Always remember, in the rectangle, the opposite sides are parallel. Question number 16. Draw a perpendicular to AB from A and name it as P. Right. So to draw the perpendicular, take your protractor, keep it like this. Perpendicular means that line forms 90 degrees with the line AB. Keep it like this, and where it forms 90 degrees you put a small dot, right, and then bring it and draw that line, and then measure and check if it's 90 degrees. Yes. So we have but it has to be from A. So we construct the perpendicular from A. So take the base as A here, 90 degrees, draw the dotted line dot there, and now measure this, 90 degrees, correct, and now you can mark this one as P. Name it as AP. This is AP. Right. Page 3 now. Question number 17. Indicate how to obtain the answer of -4 plus +6 using the number line. So we're starting with -4, that is here. Plus, and this plus So these two pluses will give us plus 6. Negative 4 plus 6. Plus 6 means we have to go to the right side by 6. 1, 2, 3, 4, 5, 6. So we end up at positive 2. Right. Question number 18. Find the value of negative 2 over 5 plus negative 2 over 5. Right. So negative 2 over 5. This plus and this minus add up and give. Sorry, when you plus into minus, it will be minus 2 over 5. Right. Now, since the negative is common to both, we can take it out. It will be negative 2 over 5. And from this negative, if I take the negative out, it will be positive 2 over 5. Multiply out and see. Negative into this is negative 2 over 5. Negative into positive is negative 2 over 5. Right. Now, inside the bracket, we can add 2 over 5 and 2 over 5 becomes 4 over 5. And the negative is outside. So, it will be negative 4 over 5. Question number 19. Write a time which the angle between the hour hand and the minute hand of the clock becomes an acute angle. Right. Write a time. So we draw a clock like this. Okay. In which the angle between the hour hand and the minute hand of the clock becomes an acute angle. So if I take the minute hand here and the hour hand here, this is 3 p.m. At 3 p.m. it's a 90-degree angle. At 3 p.m. it's 90 degrees between the hour hand and the minute hand. At 3 p.m. it's 90 degrees. For it to be acute, it should be less than that. So if I make it instead of 3 p.m., if I make it 2 p.m., it will be something like this, smaller. So we can write the answer as 2 p.m. Right. Question number 20. According to the data in the given figure, name an obtuse angle. Obtuse angle is larger than an acute angle but smaller than 180 degrees. So if you take AOB, that is acute. AOC it's 90, right angle. AOD is obtuse. AOD is obtuse or EOB is obtuse. So we go with AOD. That's the end of part 1.